In number 1, we have a system of two equations, 1, 2, and two unknowns, or two variables. The variables are x and y. Now, a system of two equations and two unknowns almost always has one solution, which is a pair of numbers, one value for x and one value for y. In this example, we're asked to only find the x value of the solution. So that means we want to eliminate y and then solve for x. Okay. Now, how are we going to eliminate y? Well, our method is going to be simply to add the equations together. Now, at this point, if we add the equations together, the y column does not cancel. Okay, minus 6y plus 3y is not equal to 0. It doesn't cancel out. We want to add them together and get one column to cancel. So we're going to have to do a little bit of adjusting with some basic operations so that the y cancels. Again, if we want to find the x value, we must eliminate the other variable, eliminate y. All right, so let's look at this y column. We have a minus 6 here and a plus 3 here. And what we're going to do is multiply both sides of the equations by numbers so that we do get the same number here with opposite signs. Okay, so if we multiply the bottom equation by 2, then we'll have a minus 6 here, like before, and here we'll have a plus 6. So when we add, we will get some canceling. So that's what we're going to do. We're going to multiply this equation on both sides, all right, because we always have to multiply both sides. We're allowed to multiply both sides by the same number, so we're going to multiply both sides by 2, again, so that we end up with minus 6 and 6. Okay, now we're going to rewrite the entire system of equations. So let's do that. Just copy over the first one. Nothing's happening there. Nothing's changing. And the bottom we will multiply through by 2 and then write it underneath. So here we have 2 times 3, we have 6x plus 2 times 3, 6y equal 2 times minus 1, minus 2. And the reason why we did that is because now when we add, the y's do cancel. Okay, and we'll be able to solve for x. We want to find x. All right, so let's now add these together. So here we have 11x. These cancel. That's how we arranged it. And this is minus 1. And just continue solving in the usual way for x. Divide both sides by 11. And we have x is equal to minus 1 over 11. Now we won't continue and figure out what y is in this example because we were only asked to find the x value. In number 2, again, we have a system of two equations and two unknowns, and this time we're asked to find the y value. So we are going to try to, in that case, eliminate x, so we'll be left only with y. And again, the only method that we have is adding the equations together. So let's look at the x column. Well, here we have a 6 and we have a 9. So obviously if we add these together, they're not going to cancel. We want this column to be same coefficient, opposite signs. So the only thing we can do is multiply both sides of one or both equations by a number so that that happens. Well, let's think of a number that 6 divides into and 9 divides into. The smallest would be 18. So we can multiply the top equation by 3 and we'll get 18 over here, and the bottom equation by minus 2 and we'll get minus 18 over here, and then when we add together we will get our canceling. Okay, so that's the plan. We're going to multiply the top equation by 3. Remember, we want 18 and minus 18. And the bottom equation by negative 2, that's for that minus 18, so that we have our canceling. Always both sides. Now let's rewrite our system of equations. So the top equation is 3 times 6, that's 18, x minus 3 times 3 minus 9y is equal to 2 times 3 is equal to 6. Okay, now for the bottom one, minus 2 times 9, that's minus 18x. Minus 2 times minus 7 plus 14y is equal to negative 2. Okay, now we want to eliminate x, and now look at the x column, 18 minus 18. Add these together and they cancel. Okay, now let's add minus 9 and 14, and we have 5y is equal to 6 and minus 2, that's 4. And we can just now divide by 5, and we have y is equal to 4 over 5. So that's the y value of our solution. We're not going to continue and get the x value because we're only asked, in this example, we're only asked for the y value. In number 3, we want to find both the x and y solutions, so we just have to decide which variable to eliminate first. So let's say we eliminate x first and then solve for y. If we eliminate x first, we need the same thing, same number in the first column with opposite signs. So the smallest number that both 2 and 3 divide into is 6. So we're aiming for 6 and minus 6. Alright, that means we're going to multiply the first equation by 2, both sides, to get that 6. And the second equation by negative 3 to get that minus 6. Alright, so rewriting the system, first 2 times 3, we have 6x plus 2 times 5, 10y is equal to 2 times minus 7, that's minus 14. And the second equation, we have 3 times minus 2, that's minus 6x, minus 3 times minus 3, that's plus 9y, is equal to 8 times minus 3, that's negative 24. Now when we add, we get canceling, just like we planned. Here we have 19y equal to negative 38. And now we just divide by 19. And we have y is equal to negative 2. And now we want to figure out x, so we take either one of the original equations. Let's say we take the top one, and we substitute this value that we found right here, and then we'll be able to figure out x. So we have 3x, this is a minus 10, is equal to negative 7. Alright, now add 10 to both sides, and we have 3x is equal to 3, divide by 3, and we have x is equal to 1, that's our x value. Alright, now we could check by just substituting in x equal 1 and y equal minus 2 in both equations. Alright, so if we have, let's say, a 1 here, that would be 3 times 1 is 3, and a minus 2 here. Okay, so that's 5 times minus 2 is minus 10. 3 minus 10 is minus 7, so that's good. And then do the same with the other equation, and you'll see that these two solutions do satisfy both equations. In number 4, we have an equation involving absolute values, and we want to eliminate these absolute values. So we're just going to reason this out. If the absolute value of the left-hand side is equal to 4, that means what's inside here must be either 4 or minus 4. So we remove absolute values in that way. We say maybe 3x minus 1 is actually equal to 4, or maybe 3x minus 1 is equal to negative 4. Okay, and then solve each equation. In both cases, the absolute value would be equal to positive 4. So solve these, add 1 to both sides, and we have 3x is equal to 5, divide by 3, and x is 5/3, that's one solution. Add 1 to both sides, to solve the other equation, and we have x is equal to -1. So we have two solutions. In number 5, we want to first get this equation in terms of solve for the absolute value. So add 23 to both sides. So the absolute value will be isolated, and then we'll do the same thing that we did in the previous example. Okay, then we're going to reason it out the same way. If this in absolute value is equal to 23, then maybe 2x plus 1 is actually equal to 23. Or maybe 2x plus 1 is equal to -23. And just solve both equations. Subtract 1 from both sides. And divide by 2. And we have x is equal to 11. Here, subtract 1 from both sides. And divide by 2. And we have x is equal to -12. Number 6 is a different sort. All right, remember, let's just look at something on the side. Let's say we have the absolute value of variable x less than or equal to 5. Let's think about what numbers could x possibly be. Well, x could be 5, 4, 3, 2, 1, 0, or it could be negative, -1, -2, -3, -4, -5. In absolute value would also be less than or equal to 5. Not -6. In absolute value, that would be too big. We can also have decimal numbers like 4.9. Okay, so if we were to write down what we just said, we basically said that x can be anywhere between 5 and -5. So this is how we open up absolute values when we have a less than or a less than or equal to. We open it up into a double inequality. So that's what we're going to do here. So we put the 2x minus 1 in the middle, and we say 2x minus 1 must be between 5 and -5 in order for the absolute value to be less than or equal to 5. So we get a double inequality, and we solve it the way we usually solve double inequalities. We'll add 1 to 3 sides. And divide by 2. And so we have x is between 3 and -2. In number 7, we reason the same way. Here, whatever's inside is an absolute value less than 7. So we say 3x plus 1 must be between 7 and -7. Now this time we use a less than symbol because that's what we have over here. And just solve in the usual way. Subtract 1 from 3 sides. And now divide by 3. And we have x is between 2 and -8/3.